everybody, good morning. I'm doing this video again. I did it yesterday, but there was some problem in the mic and the sound was very weak. So I'm doing it again. So this room is part of TryHackMe, the new path web application teaming. This room I didn't do before. So this one, length extension attacks, learn how hash function enable attacker to extend and manipulate data using length extension attacks. So task 1, introduction. What are hash function and why do we care? Basically the whole things of this length extension attack is about hash function MD5 SHA-1, the weak ones, the old one that you're not supposed to use them anymore. So hash function are one of those two that might seem hidden in the background but are incredibly important for protecting data. They take any amount of input, whatever it is, tiny or huge. If you're familiar, for example, you download something and it tell you to verify your download, and it tell you or run MD5 or SHA or something to confirm, or if you do malware and you do SHA MD5 for that binary, you go to ViceTotal and you search for that MD5 value, for example. Any change, even small change in input, we create completely different hash, and that's why it's very important. Objective of this room is have strong understanding of what cryptography hash function are and why they are essential for data security. Learn how length extension attack exploits certain hash function. Explore scenario where these attacks might be used in a real-world system. Gain practical hand-on experience in identify and exploiting length extension vulnerabilities. Some prerequisites is like some basic cryptographic hash function. There's a room for that. Let's see what on key property like pre-image resistance. Not really. Simple scripting. Python is good too for this. We're not using Python for this room. I'm not sure what I talk about. We use Python. I will do in a script, but this room is not using it. So basically, they tell us to add this to our to our host function. So let's add it now. vmtc hosts. So basically we have le length extension attack dot tryhackme. So it means the labs are there. So now we have two labs we work later on. One is attacking signator, the other one is modifying a signed cookie. Now after we finish that, so we can check that one. Now let's get to task 2. Hash function, a key property that make hash function secure. Now there's three things: pre-image resistance, second pre-image a pre-image resistance. If someone sees the hash, so if you give them the hash, they shouldn't be able to figure out what the origin. The whole point of the hash function is one-way stream. You give me something input, I give you the hash. If I give you the hash, you can't go backward. This is critical for things like password storage and things like that. At most password you give them in hash. Second, pre-image resistant. If someone has both the message and its hash, it should be very difficult to find a different message that produce the same hash. So it means if a little change in the message, it will give you a total different hash. Not like, for example, I change one letter in the document and suddenly the hash just changed in the beginning of value. The whole thing will change. Collusion resistance. A hash function is designed so that it is computationally infeasible to find two different input that produce the same hash. Why collusion? Different input with the same hash theoretically exist. The goal is to make it practical impossible. Basically, in most of the time in cryptography is always about time. So even if it's possible, it will take thousands of years. I know, with quantum computing is coming, so that's another story. Now the next one is what hash function used. We use it for anything like file integrity check. You download file. When you download the file like software or update anything, you check the hash, so make sure it's not tampered with. Storing password. When you create a password website, don't store it directly, instead they hash it. So digital signature and certificate hash ensure that document or transaction haven't been altered. For example, in email encryption or SSL certificate hash function verify that data has remained unchanged and trustworthy. Vulnerability in hash function, or even though hash function are generally secure, not all of them are created equal. All the hash like MD5, that's why this one you're not supposed to use anymore, only for simpler things like because they are fast, like MD5 still used. For example, you get a binary, you just create MD5 and go to virus total and things like that. And that's what came length extension attack, that we will check later on in the next task. Let's see, what property prevent an attacker from reversing the hash to get the original input. This is a resistance. Where is that resistance things? Pre-image resistance, you can't that whole. Sometimes TryHackMe use different terminology. The next one is what property ensure that no two different, this is the collusion part, no two different messages produce the same hash. This is about collusion. No, the resistance, yeah. Now let's go to hashing internal. How hash function process data. Now here, do they go into that big math? Yeah, that big math, complex math. This is you get very confused if you want to understand the whole math behind it. Honestly, you don't. For pen testing or something, if you want to understand cryptography, maybe this is long. And then when you arrive at this is very strange because these two results are not. I don't see them is SHA-256 for the TryHackMe keyword. That's my issue with this room. So hash functions like MD5 SHA-1 and SHA-256 don't process data all at once. That's what they call them the block. They use a block, not stream type of cipher. Instead, they break it down into fixed aside chunks. For example, SHA-256 uses 5 to 8-bit blocks. If the data doesn't perfectly, so basically if you give it word like there's no blocks, they add extra. That's why we call it padding. Padding basically put 1 and the rest of 0, so you can arrive to the block. So if I have 500 and I'm missing 12, I put 1 and put 11 0 to confirm that the full 512 is finished. Of course, the padding is important because data alignment, the data need to be aligned to the exact block size. 512, for example, for SHA-256, padding fills up the remaining space. This one is better by example. For example, you talk about, let's say you have a message that are 448 bits long, so it's missing from the 512. So the missing part, how much? 52, 50, 12. So I'm missing 24. What? Sorry. 52 46 46 bit missing, so you add 1 and then 63 bit zeros, 1 and 60 zeros, so to arrive to close the gap, the 512. So 448 1 bit and 63 zeros, so we have the 512. So whatever is missing, we just do that. So if you message exactly 448, we fit into one block. Now hash function work. Every hash function is different. This example is talking about the 256, which has 8 words A, B, C, D, E, F, G, H in internal state. That's how do the rotation in the block. This one, a block size is 512, internal size is 128, split in 4 registry. So this one has 4, this one has 8. This one, this one, MD5. This is the SHA-1. Then they go with the 2.5 now with the 8-word block and the whole the 2.5, then the padding, and then how we do the calculation. If you try to understand this, is very confusing. The result at the end is a bit more confusing because it give you this data. This is not a 256 for TryHackMe for some. Then I gave this data to Claude and I told him do me a simulation because the SHA-256 for TryHackMe is D39. I'm not sure where I got these two from. In any case, so basically that's how. First of all, to convert, so we have that the string. It's a 72-bit 9 bytes, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the hex configuration. So everyone is do that. So we have 72 bits because 8 by 9 is 72. The next one, the 256, it add a padding. So we have 72 bits, we add 1, then we add 375 0-bit, and the 64-bit length, and then we get this 512-bit. This is how the SHA-526 work. So now we got our padding. The next thing, the word. Remember we talk about the break it into 16 blocks. The 512-bit message is split into 16 blocks of 32-bit each. So W0 to W15. If you go here, is this the part of TryHackMe, or is that W things of TryHackMe? This is W0 to no, in TryHackMe start doing that 32 blocks. No, this is I try to understand it, guys. It just confused me. So you have this 32 split it in 16 blocks like we have here. So 16 blocks in 32-bit, we have 512-bit. The next one is expand to 64 blocks using bitwise operation rotate shift x XOR. We create a 48 more blocks from the original 16. And then you have all these mathematics in the back end, and then that's our blocks. That's 64 words ready for compression round. Now the next one is the wording. Remember we said it use 8 word, the SHA-256. We have 1, 2, 3, 4, 6, 7, 8. That's the 8 ones. The SHA initialized value. The SHA-256 start with 8 predefined constant H07. That's we call them 8 the words in SHA-256 driven from the square root of primes. So we have this. Then the next one, the process the 64 rounds. Each of the 64 blocks is mixed with the hash values in complex bitwise operations. 64 compression round, and you can see round 1, round 2, into round 63 we start with 0, so 64. Each round uses one y block, apply that, apply some mathematics there, and at the end we have final hash. After a round, combine the 8 value 07 into 1256 bit hash output. After 64 round, concatenated H0 H7, and then when you combine this 8 ones, and then we get the final hash. This is a fingerprint of TryHackMe. Now I don't know where this came from, but I'm not sure, guys. This is if you want to go deeper in cryptography, that's you can go, but that's it is. The block size for SHA-256 is 512. This one is straightforward. What function enabled data is aligned to fit block size. That's padding. We talk about the padding, and how many words? The words we talk about H0, 1, 2, 3, 4, 5, 6, 7. So it's 8. We start from 0, so we count that 1, and we dot. The next thing, extending length extension attack, which is task 4. Now, a length extension attack take advantage of our certain hash function process data, especially it works on hash functions like MD5 SHA-1 and SHA-256, which are built using something called Merkle demigod construction. This hash function let an attacker take an existing hash and add extra data into the message that the hashes are present without even need to know the original message of the secret key used to create it. So basically, this one is more to understand also with the practice is how does it work. For the length extension attack, it to be possible, the attacker need to know two things, a couple of few things. They must know the hash, what it use. They need to know the length of the original message. Sometimes they guess it, try each into one word, and they need to understand how the padding rule work for specific hash function. Here is more visualized. For example, we have a message user equal test, length attack extension, original message. Padding is added in to the message to make it correct block size. So for example, we want to add admin equal true. The hash is generated based on the original message, and padding. The attacker used the original hash to generate a new hash for extended message. Result valid hash. Now, why it work? This attack work because how the internal state of the hash function is carried over between data blocks. Again, we're going back to cryptography, doing deep to understand. I don't think it's easy subject to understand this one. It's more because that's why we're using native tool and Python script. So by anything that usually that's what the problem is. That once you have the MD5, the SHA-1 and SHA-256. And of course they said, for example, 2.5 wise stronger than MD5 and SHA-1 can still be exploited in length extension attack if used without additional protection, and HMAC is well known for the protection. So that's why the question here, what hashing method prevent length extension attack by using secret key is well known, because when you include the secret key in the HMAC, basically the length extension attack will not work, is dead in finish. Now, first of all, the tool they tell us to use is in rooms length extension. So let's go to the tool so we can know where we are. CD rooms length extension. Let me quiet this one. They don't need to make noise for me. The tool is that the hash extender. This one, that's what we'll use for this room. Now we're starting with this one. Now this is the lab what we're trying to do now in this room. Let's go there. For example, if you go here, you find product 3, product 2, product 1. If I do, for example, product 3, this one, it says that, but the first thing, whenever you do, always make it a habit so you can see what's going on in your computer, in your system. For this room, there's nothing special, but you can see it from the browser bar, so we don't need that's a normal queries. If you look to the bar, you see this URL, because that's the most important. This URL, you see it in the top, is the same. I'm showing it to you here. It's a get things, and then we have a file 3png, and we have a signature equal. So we have a signature here. That's interesting. For example, if I want to change the value, let's say if I say there's an image called 4, it tell me straight unauthorized. We can't, because it said unauthorized access. So if I try accessing different images, I can't. So it means I can see image number 3 here, but anything else I can't. So it means I need to know, if I want to check any other images, I need to check, I need to find the signature. And that's why length extension attack, because now in TryHackMe, the room, they give you the original script for this room. So it requires this, so the data, the secret is there. So it used SHA-256, and then you can see it wants a signature. So we have a signature there, and we have the images. There's an image folder where the images are. So it calculates the signature. If the signature is correct, it give you will see the image and you get the file. So if we don't have the signature correct, we don't get in anything. Now we're trying to get so it means there's an image inside this image folder called for PNG that we need to access to it, but we don't have signature. So basically now we need to change, because basically like here we take another image and signature and try to amend the image. Now let's try this one. Let's copy this. TryHackMe example was used for image number 1. Let's try it for number 3. This is our image number 3. We don't need to copy everything. Let's try something different. So I'm doing it for image number, what I'm doing here. I'm doing it for image number 3, the one that we're looking at now. So you don't need to copy and paste always. So my signature in number 3, for example, here I'm trying this one. I can take this one, I can put there. So basically we're trying to add this there. We're trying to access image number 4 that we can't access now. Now of course now that's because we know it's SHA-56, we can just take this new signature and I can just go there, remove this one and put new signature, but still that's a signature, and then we need to get the string that we need to change. That's our value. So now before we have a 3 for PNG, now we have this long string there. Now if I do that, I can find this one. Remember guys, you could solve this in different ways. You can just do this, you can just do that, and you go to images folder, and then you just access for the PNG. This room is not protected, so they're supposed to protect it, they didn't, but any case. So now what happened here? So now we've been able to access we've been accessed extend, that's what it is, length extension attack. And now we got our flag. Let me type this flag quickly. What's the flag? 3HM L3N 6TH underscore 3XT double 3NS 10 and 4S's. Let me see, did it correct? 4S. Let's test it. Here you use use BEP. You can use BEP if you want. Yeah, the same things. What TryHackMe is doing here? Let me put this one back. What inspect? Well, let you see what the how it was how it was injected. Why is it not going up? So you can see images 3. What the hell? H. What I'm doing me? Maybe page source. Image 3 H for PNG. What the H is doing there? Interesting. Images 3.png H. That's interesting. Huh. I'm not. I don't know what's that for. Any case, guys, I'm not. It's early morning. I'm already sleeping now. So that's how you do we've been Python designators. So I don't know. I need to think about that. The next lab is the cookie. They give us this lab. What's this one? User. Okay. Where's that lab? Let me see. Let's go to the cookie things. As always, let's activate our network tab. Let's see what TryHackMe is doing here. Is there register in this room? Let me do something I didn't try it before, but I'm curious because if you can register, you can trick it. Directory MySU MySU no, let's give me minus x php. Ah, they're smart. They input register, because if you do register, I think there's a faster way to solve this. So there's no register. You only have login, dashboard, and secret.php. There's no register.php. Okay, it's fine. They tell us to go with user. Let's go with user. Password user, and then if you enter, you get this authentication username user role equals 0, so you can guess what's you're supposed to go. The storage, if you go to our storage here, we get the interesting part is we have this one. Why is not moving? Doesn't want to move. Okay, we have this. Oh, we can see it here. Username user and role equals 0. So basically you can argue if we change role equals 0, let's say what equal role equal 1, but if you do that, it said you sorry not authorized, so it means we don't have the correct signature. So basically we need to that changing that alone doesn't, so we need to find a way to get this hash value for the role equal 1. So how to do it, because this is script is a PHP, always they're using PHP ironically. So we have this, it's so we know it's a SHA-256. So because if registration was on, we might able to create a user with the name admin role equal 1 or something. I didn't test it, but it's possible. So if a role equal 1, so we just need to go to 1, but we just need to have the correct hash. So the auth cookie contain user data like username equal user, role equals 0 to indicate a regular user. The SCSH cookie is the SHA-256 signature generated using the secret key combined with the auth data. The server check if role equal 1 exists in the auth to grant admin access. So basically we're trying to change. So the idea here is we're using the same things. Now we can use the same things, or we can use a Python script for these things. Where is that Python script? This is basically our this one, the B things. So in Python we can use hash pumpy requests. We give it there. That's the rule 0, the original. We want to add rule equal 1, key length 8, assuming because we use SHA-256, and we can try this one. Let's try that, the Python, then we can try the one also, that one. For Python, when you don't get confused, always just video environment, because Python always complaining, so slab binary activate. I think we need to install some stuff, but let's see what okay, pipe install hash pumpy. Quick, and then we can test the other one. And now we don't have a request. Pick install requests. And now if we run our Python, it give us the new data. Let's take that data there. So we can go now, because this one we try to modify, it tells us no. So we can put that there. And then we can put the new hash function. Oops. And if I refresh, I'm admin. Now let's do it now as TryHackMe did it with this tool. Let's do that. I will put an L later on. Copy. Let's test it with. So basically the same things. You give a signature. This one has too much option, format. Let's go back first of all so we don't cheat. Is there a logout? Let's log out, so we log out. Now we put user, password user, we come back, rule 0, our cookie is there. Now let's rust this hash extender. It gives us now a straight, so we can copy that one too. The new hash, remove that one, remove, paste. And then we just get the new data as the same as Python script gave us, and refresh, and then we are admin. Control C. What TryHackMe did? TryHackMe, they like using burp. Yeah, they're using burp, too much burp. I'm a lazy person. I like to use these things, simpler things, with don't make things complex. Next task is a task 7 mitigation technique. A while length extension attack can pose a serious risk to systems that rely on variable hash function. There are straightforward way to protect against them. Most of them is just HMAC is well known. Preventing length extension attack, use HMAC hash based message authentication code. One of the best way to stop length extension attack is to use HMAC. HMAC is designed to prevent attack by combining a hash function with a secret key. That's the key part of this, because attacker doesn't know, and the secret key get used in different rotation inside that hashmap mathematical process. The secret key is mixed with the data before the hash is generated, so an attacker who try to add extra data will not be able to calculate the correct hash without the key. That's where the problem for the attacker will be. Since the key is required to generate the hash, this process prevent length extension attack. Here's an example, for example, in Python. HMAC import hlib for, and then the key, the message, and you can do HMAC hash. with HMAC in place, even if someone tried to mess with the message, they won't. That's why it's used in Signate and all of that. Stop using, of course, the key point here. Do not use MD5 SHA-1, even SHA-256. You can use straight SHA-3. You should use more modern alternative like SHA-3, and ideally always use them with HMAC, so make it a habit. Use established security protocol rather than trying to build your own. Don't use your own. Rule in cryptography, never use your own stuff, so use Oath or use JWT, JSON web token, even JS web code, and you need to know how to configure them. JWTs signed with HMAC SHA-256 are resistant to length extension attack because the security is needed to validate the token. And done. As a conclusion in this room, task 8 in this room, we have discussed length extension attack and explored how certain hash function like SHA-256 can be vulnerable if not handled properly. Key takeaways: understand hash function. Know how cryptographic hash function work and why properties like pre-image resistance and collusion resistance are crucial for security data. Exploiting vulnerabilities: we have seen how attacker can modify hash data and generate a valid signature, a real-world impact from forging signature to alternate signed cookies. We covered how these attacks play out in real life and the risks they pose. Of course, mitigation strategy is of course using HMAC with secure hash function like SHA, or use SHA-3 directly, and that's it. So we're done with this room. The labs are cool, so we use both of them. This one we use also the small Python script. What do we did there? No, this one is also a length extension attack, and this one is, yeah, this is our Python. Yeah, sorry guys, this is I redo this video because I hope the sound is good, because I'm not sure I'll make it 3 times now. Thank you very much and have a good day.